sure you read number 1. It's not asking for an answer. Alright, I'm putting the scholars work up on the board number 1. Today, I do appreciate somebody trying to use a number line for the first one. It is possible, just a little more difficult. So, the scholar has an area model on the board. Let's talk about where the sites came from. I need someone to help us. What do the rows represent in this problem? What do the rows represent? Help us out. Help us understand this, because this is what we need for our test. Ava, what do the rows represent? Do we have 3 rows?
Oh, I mean the one.
So this scholar started with the first number as the rows. Now here's what I'm going to tell you. If this was a test, this scholar's exactly right. But if this was a test and it was asking you to identify it, it would have the entire row shaded. So then what does the columns represent? What do the columns represent? Lawrence? What do you mean free? Oh, I'm sorry. I was thinking of a different problem. You're right, the 3. The dividing by 3. Now, once again, if this was a test, it was asking you to identify, I'll use a different color, it would have it shown like that. And then what the scholar did with shading the 1, I'll show you completely, this is what it would look like on the test. Now, for the purpose of this, what the scholar did was exactly right. Once again, some of you are trying to use a number line. It is possible. A couple of you did it correctly, which is great. I think when you start with a fraction, it's easier to use an area model like many of you try. Any questions on number 1? A couple of you were close. You just need to make sure the number is represented. I'll tell you what I mean. Some of you had 2 columns, and I asked what it represented. I just wanted to make sure that you had the 3 columns that are represented, or 3 rows, depending on how you set it up. All right, number 2. We haven't done a division problem in a while, but we have been working on the decimals. So here's what I wanted for number 2. I saw a lot of you doing a good job with moving the decimal on the outside, moving the decimal on the inside the same amount. The common mistake, I didn't see it much today, but when we first did this, a lot of you just wanted to move that inside decimal all the way to the end. Remember, it moves the same amount as the decimal on the outside. I see your car copying this down, which I appreciate. See Makai copying this down. You see Marcus copying this down. We haven't worked on the division much lately, but we have been focusing on how to move those decimals. And then number 3. Number 3, I didn't see, many of you haven't set up yet because you're still working on 1 and 2. So I'm going to show you how my mind thinks, how I broke it down, kind of like how we've done the last couple of days. So it says Gabe jumped 4 feet 7 inches. And it's asking us to convert that to inches to see how high he jumped. So my mind first jumps to the 4 feet. I know I need to convert feet to inches. Feet is larger than inches, like we worked on Monday. So that means we need to multiply those 2 units. So 4 times 12 gets us 48. And then the nice thing about this problem, there's no fraction to work with. It just tells us an additional 7 inches, so I added it to the 48. So he jumped a total of 55 inches in the high jump. Any questions on the do not? Okay, moving to page 2. Go ahead and go to page 2. Page 2 is our fluency. We haven't done one like number 1 in a while. So we're going to go into the mind of Mr. Diaz and how I think about these problems. Try to make it a little bit easier. So the first thing I notice, I'm dividing 2 numbers that end in zeros. So the first thing my mind wants to do is make these numbers as easy as possible to work with. So I'm going to go to each of the numbers, and I'm going to eliminate the same amount of zeros. So 50 only has 1 0, which means from the 30,000, I can only eliminate 1 0 as well. So now I have 3,000 divided by 5. Here's my next thought. What can I divide 5 by? I cannot divide 3 by 5. I can divide 30 by 5. So 30 divided by 5 gets me 6. Now, we've worked with this. Those extra zeros that I ignored, I'm just placing those at the end of my answer. So this is just a quick way of using mental math with larger numbers. Sections 2 and 3, things that we've been practicing the last couple of days. So we're going to need to review those right now. 2 minutes working on both speed and accuracy on page 2. Your 2 minutes at a level 0 on page 2 starts now. Amelia working on a 0. Elijah working at a 0. Lawrence working at a 0. See some of you skipping right down to the second 2 sections. It's a big test taking strategy. Do those problems you know first, and then come back and do the other ones when you have time. Alright, here are your answers for the top section. For each of the problems, I showed you the crossing out of zeros to simplify it. I underlined the numbers that you were able to divide. And then the zeros that were left over, I just placed those zeros at the end of my answers. So while you're copying these down, make sure you are copying those steps. You don't need to do it for every single problem, but do it for a few of them. Cross out those zeros. Underline those numbers that you're able to divide. Once again, you don't need to do it for all of them, but do it for a couple. Alright, now we have our second section, which I'll just bring them both up. Second and third section, just adding and subtracting multi-digit numbers, what we've been working on, showing the regrouping when needed. Any questions on the fluency? Alright, here's the nice thing about today. We're practicing what we did on Monday and yesterday, but today, we're not just focusing on one thing. Monday we focused on converting larger to smaller units for you to multiply. Yesterday we converted smaller to larger, we had to divide. Today, you have to identify which way we are moving. So here at the top of page 3, this anchor chart, just like the last 2 days, is really going to help you out. Think about, is it smaller going to larger, larger going to smaller, and do you need to multiply or divide? Alright, we have our triad. I'm going to read it to you, and then I'm going to give you 3 minutes. You're going to reread it. Use cubers. Jillian makes 10.5 gallons of lemonade to sell in 1-quart bottles. How many quarts of lemonade can she make? Once again, you have 3 minutes. You're rereading it using cubers and doing the best you can to solve it. Your 3 minutes at a 0 starts now. Italians use cubers already. Price is using cubers. Florence has used cubers. Guys working at a 0. Zion's at a 0. Lawrence is at a 0. This is numerically at 0. Alright, on the board I have a reference sheet that might help you out. Sorry, I meant to put that up about 30 seconds ago. It does not give you the conversions, so that reference sheet that you're able to use on your iReady and your OST is on the board. All right. Let's discuss this. So here's the first thing I want to do. I'm going to use cubers to demonstrate what many of you did. Let me do that. All right, so I circled the number, underline the question. I'm going to box in with some important information. First thing is the units for what they gave us and what they are asking us to convert to. So my first question is, What is Jillian making? What did Jillian make? It's right in the problem. What did Jillian make? Marcus. She made lemonade. How much, Marcus? Close, 10 and a half gallons. So that's what we're starting with. That's the number they give us. What are we converting this to? We got it. What are we converting this to? 10 and a half gallons to Zaire, Jay, help them out. What are we converting this to? Now, this next part, this is what I had you write the last 2 days. This is what's really going to help you out. Think about it. Which one is larger? Gallons or quarts? I'll say it again. Which one is larger? Gallons or quarts? You're just going to turn to your partner and you're going to quickly say, which one is larger? Gallons or quarts? Turn and say it. Good. Okay, so I heard gallons is bigger. So we're going to write this underneath. Larger to smaller. Now I'm calling someone to use the anchor chart at the top of this page. Riley. When we go from a larger unit to a smaller, using that chart, are we going to multiply or divide? There you go. This is our little trick. So that means we're taking this 10 and a half and we're multiplying it. But it doesn't give us a conversion rate. Fortunately, our reference sheet did. Who remembers from the reference sheet how many quarts are in 1 gallon, Haven? 4. All right. Also, the last 2 days, we made this easy. I don't want to multiply 10 and a half by 4. You don't want to multiply 10 and a half by 4. What can we do with that 10 and a half? More than one person should remember when we deal with these fractions the last 2 days. What can we do with that fraction? Right? What can we do with that fraction? We could, but that's still going to make a lot of work. Bryce? Haven?
Break it up like 10 and then 1 and then times 4 and both of them.
Yeah, we're making this easier to do it mentally in our head. 10 times 4. Most of you can do that in your head. 1/2 times 4, that gets a little tricky. We rewrote that the other day. I'll rewrite it again, just so you can see it. Ten times 4, say it, what is that?
40.
Alright, so 10 times 4 is 40. Here was 1/2 times 4, a way of writing it so that it makes sense. Half of 4. What's half of 4? 2. Now you gotta think, what do we have to do with these two numbers? Lawrence, what do we have to do with these two numbers? Not multiply. Damon, you add them, so go ahead and do that on your paper. 40 plus 2. And then you have broken down this problem to make it easier, not easy, but easier to work with. And Elijah's going to tell us what you get when you add those two numbers together. Say it again. 40 and 2. I'm sorry, I'm on your way. And then the last thing, this is a sorted problem. 42 quarts. Once again, there's nothing easy about this, but we can break down numbers to make it easier to think about. Any questions about this? page 4. Page 4 is your partner practice, but I want to explain the top because I know what's going to happen if I don't. The top part, once they finally heard it, it's asking you to show if they're equivalent, each of these six are equivalent to 1 foot, 1 yard, or 1 inch, or none. So you need to read through each one. Then you and your partner need to talk about is 36 inches equal to any of these. If not, you're selecting none. If they are, make sure you're selecting which one it is. And then there's a problem. Oh, don't copy those inches down. I just made it. Then there's a problem at the bottom. It's a difficult problem, but that's why we're doing this with partners. I'm giving you 5 minutes with your partner, working on page 4. Starting with that table at the top, your 5 minutes with your partner starts now. Or is it 9? Which of these is the same as 10? So 36 inches off is even which of those doesn't match? Be ready to share in about 2.5 minutes. Hmm? One more minute. Yes. She's not, her mom sent a message on reminds me she wasn't going to come in today. Yep, you're welcome. All right, I'm going to stop that timer 30 seconds early, so you got an extra 30 seconds. All right, possible sticks for answers. After someone gives an answer, you just use your nonverbal agree or disagree. Before we get started, let's move our desks back, move back to your seats. Give you 3 seconds to do so. Alright. Once again, you're trying to tell which of these 6 are equal to, starting with 36 inches. I won't be able to use this calculator. Marcus, 36 inches. 1 foot, so I need to see some hands if we agree or disagree. Show me what you think. Thank you, Aaron. Thank you, Natalia. Thank you, Lawrence. Thank you, Dakari. I see a mixed response, though, as far as agree or disagree. Someone tell us, how many inches are in 1 foot? Haven, how many inches are in 1 foot?
How many what?
Inches are in 1 foot.
12.
So, just from what Haven told us, 36 inches cannot be 1 foot. Obviously, which one can it not be? Bless you. Haven, which of those 4 can 36 inches not equal? Yeah, 36 inches cannot equal an inch. And we just said 36 inches cannot be 1 foot. Someone tell me, if we're going to figure out yards, how many feet are in a yard? I won't take a possible stick because we don't have a conversion table. All right, Zaire. How many feet are in 1 yard?
How many feet are in 1 yard? They are, wait, say it again.
How many feet are in a yard?
Oh, 2?
Natalia is going to tell us. Natalia, find 1 yard on that conversion paper. How many feet are equal to 1 yard? Should be on the, yeah, there you go. Say it. 3 feet. So we know there's 12 inches in 1 foot. There's 3 feet in a yard. What do you think we have to do with these 2 numbers? The 12 and the 3. How will we figure out how many inches are in 1 yard? Riley? Multiply them. 12 times 3, okay. Let's do the 3 times 2 first. What's 3 times 2?
5.
No, 3 times 2? 6. Then 3 times 1 gets us?
3.
So that means there's 36 inches in 1 yard. So the correct answer for that one was A. Now, I will tell you before we move on, some of these are really weird to think about because we don't think of them in terms of fractions. But 1/12 of a foot. 1/12 of a foot. Go over here. Lawrence, what did you and your group put for 1/12 of a foot? A yard, a foot, an inch, or none?
I put an inch.
Show me with your hands, do you agree or disagree? Okay, from the 6 hands I saw, all of you agree. I'll tell you right now, I agree as well. How many inches are 1 foot? Someone should know this. 12. Hello? Yeah, she's in the room now. Yep, you're welcome. Yeah, there's 12 inches in 1 yard, so that means 1 inch is 1/12 of a foot. But it's weird thinking of it as 1/12 of a foot. All right, moving forward, 1/12 of a yard. Elijah, what did you and your group put? 1/12 of a yard. 1/12 of a yard. Can it be 1 yard, 1 foot, 1 inch, or none? If you're not sure, just guess. Pick one. 1 foot. Show me with your hands. Do you agree or disagree with that? I need to see more hands on this time. More hands. Thank you, Bryce. Thank you, Rodrigo. Thank you, David. Okay, what do you think? Do you agree with Elijah? 1/12 of a yard is 1 foot? All right, let me explain. Help you think about this. If 1/12 of a yard is 1 foot, that means you're telling me 12 feet are in 1 yard. I'll say it again. If this is true, that means there are 12 feet in 1 yard. We just talked about how many feet are in a yard. Bryce, how many feet are in a yard? Turn on the board.
How many feet are, 3.
3 feet. So that one cannot work. We've already talked about it. How many inches are in 1 yard? Marcus, it's written on the board. How many inches are in 1 yard? 1 yard, not 1 foot. 36. So, whoops, wrong one. So inches cannot be right. Now this one, 1/12 of a yard and 1 yard, they're the same unit, different numbers, they cannot be equal. So by process of elimination, it has to be none of those. There you go. Alright, here's say 12 feet. Navion, 12 feet. What did you and your group put for that? None. Show me with your hands. I need to see all hands this time. Even if you didn't get to this one, show me if you think they're right. Thank you, Natalia. Thank you, Riley. Lawrence, let me see it. All right. Thank you, Dakari. Let's see. I agree with that as well. 12 feet. Well, we just discussed it. There's 3 feet in the yard, so that one can't work. There's 12 foot or 12 feet and 1 foot. That doesn't even sound right. And inches are small. So yes, I agree with that. Here, we got some sticks there. Haven, 1/3 yard. What did you put for that?
4 foot.
All right, let me see your hands. 1/3 of a yard. Do you agree or disagree that it is 1 foot? Rodrigo, what do you think? 1/3 of a yard. Do you agree or disagree that that's 1 foot? Show me with your hands. Thank you, Akai. Thank you, Natalia. Dyer, what do you think? No, do you agree with this? Alright, I'll tell you right now, I also agree with this, because what this means is that there's 3 feet in 1 yard. So yes, I agree with that. And then the last one, 1/36 of a yard. Bryce, what did you and your group put?
1 yard.
So you're saying 1/36 of a yard is the same thing as 1 yard?
No.
Okay, so you're not saying that. So which one then?
1 inch.
1 inch. All right, show me with your hands. Do you agree or disagree? Thank you, Damon. Thank you, Dakari. Thank you, Navion. Let's see. 36 inches in 1 yard, so 1 inch is 1/36. I agree with that as well. Any questions on this? Some of these were really weird with the way they looked. We just don't think of fractions when we think of yards. 1/12 of a yard, 1/12 of a foot, 1/36. So I can understand how these might get a little confusing. But we do need to talk about the second one. I didn't see many of you get to it. So we're going to discuss it together. So, Merciful and his friends hiked across the state of Ohio. It took them 4.5 days. He wants to know how many hours was that, or how many hours did it take them. So we're going to use cubers. The first number it gives us, 4.5 days. What's it asking us to convert to? Sorry, please. What's it asking us to convert to? Rodrigo. In the problem, it says how many what did it take them? It's on your paper as well. How many? Oh, other side.
Oh, is this 4.5 days?
Okay, how many?
Oh,
What are we converting to? How many what? Oh. How many what?
it's
How many what?
hours.
Hours. We're converting to hours.
Oh, I thought you wanted me to
Oh, I'm sorry. I didn't want
change the number into like hours.
So here's how we start setting this up. Now, this is not on the worksheet, so you have to know this. Most of you do. How many hours are in one day? Bryce, how many hours are in one day?
24.
Next thing we need to think about, which is larger, days or hours? Turn and say it to your partner real quick. Which is larger, days or hours? Turn and say it. All right, I heard some of you correct yourselves. So we're going from larger to smaller. If you're not sure, look on page 3 at the top right-hand corner. Marcus, I'm going to have you look for us. We're going from larger to smaller. Do you know what we're doing with these numbers? Are we multiplying them or are we dividing them? You can use page 3. We're multiplying. Marcus said he didn't need to know or didn't need to look because he already knew. Excellent. So we're multiplying these. 4.5 times. What are we converting it to? Zaire, what are we converting this to?
We converted the large to the little.
So what are we converting to?
Hours.
So what are we going to multiply 4.5 by?
60.
Maybe minutes, if we go minutes. Damon? 24. Here's what I want you to do next. Think. I'm going to give you 10 seconds to think. I'm going to call on someone. How can we break up one of these numbers to make it easier to work with? Think what we did for the triad. How can we break up one of these numbers? So I'm going to pick on Rodrigo. We got two numbers, 4 and 1/2 and 24. How can we break up one of those numbers to make it easier to work with? Think of the triad that we did. We had a mixed number. We broke it up. How do you think I can break up one of these numbers?
You can remove one of the you can remove one of the numbers and make it smaller. Like if you cross out the 4 or something.
Close. Lawrence, we are going to kind of make numbers smaller, easier to work with. Lawrence, what are we going to break up?
The 4.
The 4.5. How are you going to break that up? Into what two numbers?
1 and 2.
No. Haven, help them out.
So we break the 4 and 1/4 into 4 times 24, and then 1/2 times 24.
So we're breaking up the 4.5 into two parts. Now these are a little bit easier. 24 times 4, write that on your paper. Do it. Give you one lap around the room to get that done. Now we're going to call on someone to help us out with what they got. All right, 24 times 4. My victim to tell us that is not here. Not here. Look at someone else. Namion! What did you get for 24 times 4? Not quite. I'll tell you right now though, your answer is a counting mistake. What did you multiply first? Help me out. What did you multiply first? Good. You got 16. But what do we got to multiply next? Zaire, what do we multiply next? The 4 and the 2. 4 times 2 gets us what? Say it. And then, I heard someone say it. You got to add 8 to that 1, and we get 9. I will say, that mistake though is very common. I was talking to the 6th grade teacher, and I said, the thing I'm seeing a lot is we multiply the first 2 numbers, and then a lot of scholars are just bringing down that next number, but we got to multiply as well. All right. Yes.
What if you just did 24 plus 24 plus 24?
You could, but let me ask you a question. What if it said 15 times 24? Do you want to add 24 15 times? You could. For the purpose of this right window, if that's what you need to do it, do. Alright, so 4 times 24 is 96. Half of 24. Half of 24. Think about it. Half of 24. Bryce, what do you get? 12. Then Natalia, what do you think we do with these 2 numbers? Add them. Do that on your paper. (96 plus 12).
108.
All right, someone say it. 100. And then you need to label this. This is a story problem. Put those units in there. It took Merciful and his friends 108 hours to hike across the state of Ohio. I know these aren't the easiest things, but if you break them down, it makes it more manageable. Any questions on this part of practice? All right, turn to page 5. Page 5 and page 6 are our independent practice. For 1 and 2, I broke down the problem for you to help you out. I'll say that again. For number 1 and number 2, I broke the problem down to help you out. Fill in those blanks in order, and they can help you think about it. Now I'm going to put the reference sheet up because it will help you with this page. So I'm going to reduce it to 8 minutes because of time. So you have 8 minutes. Do as many as you can on page 5 and 6. Your 8 minutes at a 0 starts now. All the conversions you need for page 5 are on the board. Natalia got to work right away to 0. Damon got to work right away to 0. Makai got to work right away to 0. These things are going from bigger to smaller. Checkmate Street. Checkmate Street. One line, I think, is how many. Okay, then that is the P for Philly. One line, I think, is how many feet. Changes. Solution for the Alright, let's talk about number 1 and number 2. So here's what we're going to do for number 1. For number 1, we're going to do a quick turn and talk, and I mean like super quick. I know the reference sheet isn't up there, but it was up there almost the entire time, so you should have this written. You are going to turn and talk, and you're going to say the number of feet 1 mile is equal to. So you're just turning and telling your partner what number you're putting in that blank. Turn and say it. Excellent. I heard many of you say it, so I can pick on whoever I want. Dakari, how many feet are in 1 mile? 5,280. Now the second part. Once I came around and kind of helped many of you, you knew what I was asking. When going from a bigger to a smaller unit, you blank your numbers. Are we multiplying or are we dividing if we go from a bigger to smaller? Take 5 seconds. Turn to your partner and just say it. Are we multiplying or dividing?
Multiply.
Excellent. Now I did cut off the top, and I apologize. This was for 3 miles. So everything we need is on here. We got 3 miles. We know there's 5,280 feet in each mile. We know we're multiplying those 2 numbers. I'm not going to sit here and do the math, but I do want, and I'll take a volunteer for this part. What does that get us, David? I'm going to put it down there so you can see it with the numbers. There are 15,840 feet in 3 miles. Any questions on number 1? Excellent. Number 2, we're going to do the same thing. We're converting 27 feet to yards. So the first thing is we need to figure out how many feet are 1 yard. I want you to turn to your partner and say, how many feet are 1 yard? Turn and say it.
3.
Excellent. I heard 3s. All right. Next thing. When we go from a smaller to a bigger unit, you blank your numbers. You're going to turn and say to your partner, do you multiply or divide? Turn to your partner and say multiply or divide. Excellent. Now, the numbers we're dividing, they give to us. We have 27 feet. Our conversion unit is 3, so we're dividing those 2 numbers. So here's the next thing you're going to do. I know we don't usually set up like this, but this is a fact, so we don't need to set it up in long division. I want you to turn to your partner. What do you get when you divide 27 by 3? Turn to your partner and say that answer. All right, excellent. Okay, so 27 feet is equal to 9 yards. Many of you that missed that, you had the right thing, you just put a wrong number, it's okay. You have the right idea. All right, because of time, we need to move to our exit ticket. Now, I wanted to make sure we got through 2 of those questions. Our exit ticket has 4 questions. That sounds like a lot. But the first 2 questions are to help you think. I'll say that again. The first 2 questions are to help you think. They are even somewhere in your packet. So you have the next about 8 minutes to do this exit ticket. When you're finished, you're going to put your name on it, you're going to rip it out, log into your Chromebook and work on Frax or one of your MyPath assignments and iReady. This is a great guess. I will put the conversion back up, even though the conversions won't really help you for this problem, but just so you can see. For number 3 and 4, half your points are showing work. So make sure you're showing work. Yes. I am liking this. It is a grade. Make sure your name's on it. Once again, when you finish, rip it out. Open your Chromebooks. Use your time wisely on either fracts or on your my top assignments when I'm ready. Damon's finished. Using his time wisely, logging in. Zaire finished using his time wisely, logging in. Riley's finished logging in using his time wisely. Let's just say it's like 20 something evaluation then. Here's what I do. Sneeze and cough too.
Are you sick?
It's
Oh, you still?
yeah, it's bad.
Oh, I hope you feel better.
You have about 2 minutes to finish your exit tickets. My suggestion, get some quick work on the paper, maybe take an educated guess in about a minute and a half.